All right, we're back, kids. Okay, so if I say go find the 100th derivative. Oh, yes, thank you. All right. Yes. All right, now back to the action. If I said find the 100th derivative right now without taking 100 derivatives, could you just plug 100 into your master formula? And it would be e to the x times 2x plus 201. Boom, you got the 100th just like that. No work.
Oh my God.
That's nice. Good stuff, right? And we're soon going to be learning the Wade theorem, actually.
Yeah.
Where you can just plug in a step and then boom, you got a Pythagorean triple right there. Yeah, good stuff. Nice. Oh, yes. Applause, applause. Okay, so that's that one. Now, let's do the next one. The next one is the doozy, all right? B is the one where, now did you notice that there was only one pattern here and it was this number?
Yeah.
Right, one pattern. The next one has four simultaneous patterns
Oh my God.
going on.
Oh my God.
But just treat each one as a sequence and just do one at a time. Because all it is just each a separate sequence, okay? The same sequence as we've done before, actually. All right, so let's see what we have for the next one here. I'll tell you what, in the first row, let's go ahead and just rewrite this because we need to rewrite it before we do the derivative. All right, first question, could we do the quotient rule for 1 over 1 plus 2x?
Yes, but you don't.
Sure.
Would you want?
You can also kill a mosquito with a sledgehammer,
That'd be
all
fun.
right? But you don't have to, all right? Couldn't you rewrite this into an easier derivative? So let's make that 1 times 1 plus 2x to be negative 1. That's how to do it, right? Then can you just do the what rule here? This is just the
Change.
chain rule, yeah, sure. Just do a chain rule.
Does it go in the first box?
And yeah, put that in the first row. Okay, that'll be our first. So let's just
That's how you
rewrite.
sneeze if you wait first one.
Okay. Now let's go ahead and set up our derivatives. You want to give yourself a good probably 4 derivatives because you can't see the pattern at first, but the further you go, it's like, oh, that pattern is so obvious once you get lower down there. So let's do the first 4, and then we'll fill out the other columns. Okay, so dy dx. All right, what's the first thing we do?
Bring down.
Bring that negative 1 right down to the front. What about the base? It's the same. What is the new power? 2, and the chain rule? 2. I'm so tempted, I can't believe it. 2 times negative 1 is negative 2. Usually we do that. These are all written out, right? Because we're looking for patterns, okay? Don't lose the pattern. Keep it just like that. Second derivative. Okay? The negative 1 is a coefficient, therefore it stays right there. The negative 2 goes where? Comes down to the front. What about the base? Stays the same. And the new power is 3. Now doesn't that 2 carry?
Yes.
But you get another chain times 2, just like in the cosine ones and the sine ones for the homework, right? Okay? So now you have more. Now, don't change anything. Don't combine all these together. Leave them all written out so we can see the pattern, right? All right, third derivative. Okay, negative 1 and negative 2, what do they do? Stay right there. Who joins them? Negative 3 joins them. 1 plus 2x to the negative 4. 2 carries, another 2, jumps out another 2. Okay? You are seeing behind the scenes of the pattern of the chain rule right here. This is the pattern it creates. Remember the one we did the other day that just totally collapsed? That was yesterday, right? Yeah. Because the powers went all the way down to 0. This one won't collapse because it gets more and more and more negative, so it's actually getting bigger than what's happening here. Okay? So this one will never collapse. All right, fourth derivative. Can you still see me? I don't know. Fourth derivative. On a bigger board. Actually, too old for this. All right, so, way too old for this. So, negative 1, negative 2, now come back. Negative 3, all right. Then bring down the new power of negative 4. 1 plus 2x. Can you see that low on the camera?
Yeah, you can see the whole thing.
Okay, good. All right, good. All right, -5. Then we have 2, 2, 2 all carries, but
Yeah, another one.
An R.
pretty fun step. All right,
So.
so,
Is rated R?
all right, there's that. Now, let's see. Let's go to the simplified form next. Let's actually try to simplify this a little bit, and you'll start to see a pattern. Okay, let's actually start down here first. What do you think about a negative times a negative times a negative times a negative?
It's positive.
It is a positive. Let's siphon out all those negatives and just make a plus sign in front. Let me tell you why. What does this look like right here? 1 times 2 times 3 times 4, what is that again?
Factorial.
That's a factorial, but there's no such thing
That's a negative.
as a negative factorial. Okay? So first of all, pull out all the negatives. 4 negatives make a positive. Let's put a little plus sign in. And then once you take that out, what is 1 times 2 times 3 times 4? 4 factorial. And what is 2 times 2 times 2 times 2?
2 to the 4.
2 to the 4th. And then wouldn't this move to the bottom? 1 plus 2x to the positive fifth. Okay? And there's your simplified form right there. All right? So far so good. Okay, let's go back one step to this one. Right? Okay, so this one, what do you think about negative times negative times negative?
Negative.
That is a negative. Once we siphon out the negatives, what about 1 times 2 times 3? 3 factorial. 2 to the third. Over 1 plus 2x to the fourth. Okay? I think I'm starting to see a pattern here. Good. Interesting. All right, now, take out the negatives. What sign is this right here?
Positive.
It is a positive. What is 1 times 2? 2 factorial. 2 squared. 2 squared over what? 1 plus 2x quantity to the third. Oh, yes, I see that pattern emerging right now. Okay. All right, now, this one, it's all by itself, but what sign is it? Negative. Even the minus plus is forming a pattern, isn't it? Right? Kind of like something we did the other day, actually. Keep that in mind. All right? And the number 1 is actually 1 factorial, sure. Look at the pattern, try to make it match the pattern now. 2 is actually 2 to the first, and 1 plus 2x to the, oh yeah, we got a pattern here. And then finally, even the original function is part of the pattern. And the original function, is it plus or minus? It's plus. Now here's the kicker. Shouldn't, by the pattern, shouldn't it be 0 factorial? 0 factorial is not 0. 0 factorial is actually 1, as a matter of fact. We do a little proof, I don't think we have time today, but I can also tell you this. If you take 4 random things out of a sack, okay, just a blind pick, and you put 4 things on the table, there are 4 factorial ways to do that. That's how many combinations you have, right, when you pull it out. If you had nothing in a sack, there's only 1, not 0, there's 1 way to do that, and that is put nothing on the table. So that counts as 1, not 0. So factorial counts combinations, essentially.
So wouldn't that count if you had the 4 in the bag, if you didn't take any out, it would still count as 1?
Not really,
An option?
because that's actually picking out, that's actually physically removing, all right? Very crafty, not Matt, yeah, Steve Bracelet, very nice, very good thing. But in the 0 case, it's simply there's 1 way to say I have nothing at all, essentially. And if you have something to pick, you have to pick it. Okay? And this is going to be 2 to the, well, let's see the pattern. 2 to the 0, and you know what? 2 to the 0 is 1, that makes sense. And it's over 1 plus 2x to the first. All right. How about that? Okay, we got a pattern. Okay, so let's go to the derivative column then. All right, in the derivative column, this derivative is the which derivative? Fourth. And the third here.
Yeah.
Second.
First.
First. And yes, believe it or not,
0.
and sometimes they'll use this in college, the original function can be called the zeroth derivative. Because you haven't
Zero?
done it. Zeroth, yes. That's-
New word of the day.
Yeah, new word of the day is zero. All right? Now, derivatives, okay, let's go to the denominator next. Denominator. The denominator is 1 plus 2x to the fifth, 1 plus 2x to the fourth, 1 plus 2x to the third. Oh, I see an easy pattern here. We'll get this one. And even the original was 1 plus 2x to the first. Okay? Let's try to fill out the bottom box now. All right? 0th, 1st, 2nd, 3rd, 4th. In general, this is what? Nth derivative. When you arrive at the nth derivative, which could be any derivative, you will have 1 plus 2x to the, how do I make 4 into 5, 3 into 4? It's to the n plus 1. That's part of our pattern right there. Okay? All right, now, let's do the chain column. Okay? This one was 2 to the 4th. This one was 2 to the 3rd, 2 to the 2nd, 2 to the 1st, 2 to the 0. So when you get to the nth derivative, it would be 2 to the nth power. All right? And you wouldn't actually have to make an entire table like this to do it on the test, but as long as you do 4 derivatives, you can see the pattern. Okay? All right, now, factorial. We got 4 factorial in this step. We got 3 factorial in this step. 2 factorial here, 1 factorial, and 0 factorial. Therefore, on the nth step, you will get what? N factorial. It's the same as n. Okay? And the last thing, and that is the sign change. For the signs, we got plus, this one was minus, plus, this one was minus, plus. So how do we create a positive for all the even number derivatives and a negative for all the odd number derivatives? Negative 1 to the nth power. Because negative 1 to the even is 1, and negative 1 to the odd is negative 1. So your final answer, and you can put it down below here, your final answer would be dny over dxn is going to equal negative 1 to the n covers the sign. The factorial was n factorial. And then 2 to the n over 1 plus 2x to the n plus 1. And that will instantaneously take any derivative of this function for you. That's about the maximum of the patterns we're going to do right there. That is the max. Nice timing. Looks like we're done.
Catchphrase.
Catchphrase. I still don't have a catchphrase. I gotta think of it.
Okay.
That is my catchphrase.
That might be the catchphrase. Catchphrase.
That is
Tell me the second one.
Work in progress.
Tell me your catchphrase. Oh, it's really all the way.
He's my director. You're my director. All right, say catchphrase.